All right, so let's get into this. You'll notice this should look familiar. This was kind of taken from the notes we had taken before. But what I've done here is I've very specifically grouped it differently than the first time. Okay, notice I kind of have something in bold to kind of give a small category of what we're talking about, and then I give each of these reasons, right? At the end of the day, here's what we're doing. I'm giving you guys the gavel and wig. That's a phrase to say, you guys are the judge. Here's a situation with given information, and you have to show me some evidence and line it up to get the verdict that you want. So it would be a good idea for us to know what are those reasons we can pull from to prove what we want. So let's look at it. The first category, what's that called? What did I call that category? The start, right? Because, wait, we have to start somewhere. And we're always going to start with something called the given information, right? So, given. Let's think about it. What do you guys think given means? Information that is given, that they give you. Other ways to word that, you guys think. What are your guys' ideas? Yeah, this one's kind of clear cut, right? It's information, right? Like why it's talking about information that is given to us. It even says it at the beginning. So that's our start. That's always our first domino that we have to put in our sequence. So if that's a helpful analogy, I always liked that visualization, is that I'm kind of just trying to stack my dominoes. I need my given information to start. If I'm trying to prove something in court, what happened, right? What's the thing that started this whole thing about you being in the courtroom and us having to prove something guilty or not guilty, right? So, what questions do you guys have about what given information is? Ladies, right now is not the time. I appreciate it. What questions do you guys have about what given information means? Okay. Awesome. So if it's helpful for you, this is always first. It's always first. I also want to put this here. This was a data piece that I had seen on that quiz that we had taken before fall break. It's never last. Okay? On the quiz, when I was grading it, one of the biggest things that I had seen was people who had put the word given as the last reason. Think about that. I'm trying to prove that somebody was a murderer. Well, they're a murderer because they are. Does that make sense? I look at that person, okay, they're a murderer because they're a murderer. You see what I'm saying? I cannot conclude my reason by saying that it's already given to me. Right? So it's always going to be my first reason, but it's never going to really be my last. It could be maybe in between, you might pull it again, and we've seen that before, but it's never going to be last for us. Okay? So let's get into this next portion here. Algebra. See, we took algebra, pre-algebra. We did all of this arithmetic throughout first through sixth grade. We know that we can take two numbers and add them. The addition property, subtraction property, multiplication property, and division property are all things that we know we can do because we've done them, right? Addition property, 1 plus 1 equals 2, right? Or another way to say that, I can take numbers and add them together. here's where we're in high school now, right? Like this is like 10th grade, 11th grade. Like here's where we get into the real depth or more like specific thing with this, okay? And here's what I mean. I'm going to put a parenthesis here to kind of put something together. On both sides of the equal sign. Okay, I want to break that down. What makes these algebra properties is the fact that I'm going back and forth across an equal sign. That's what we took algebra for. What are the tools to go back and forth across an equal sign to keep things equal or balanced? That's the point of what we did, right? So when we're talking about these properties, see how I kind of put that equal sign? I should be a little bit more specific. I should call these properties of equality. Of equality. All right? Because all I'm doing is that algebra stuff I learned in elementary school on both sides of the equal sign. That's what makes this special. That's what makes this particular. For all of these properties that you see in the algebra category, what I'm talking about are the things we've done on both sides of the equal sign. So when I have this thing written, 1 plus 1 equals 2, we know that that's possible on both sides of the equal sign. So it could look something like this. 3 plus 1 equals 3 plus 1. Well, of course it does, right? Because we know that to be true. But what's happening here? I'm adding 1 on both sides. That's what keeps it equal. It holds equality. That's the high school jump, okay? Is the fact that we're specifically talking about going on both sides. And that's the same here, right? Subtraction property. I can subtract the same number on both sides of the equal sign. And I think you've picked up on the pattern right now. What might a good definition of the division property look like? Think about it. The division property, what might I write there for the definition? Sure, yeah, so for the division, I'm dividing, so I might say, yeah, I can, you're good. I can divide the same number on both sides of the equal sign. So if I look at maybe a visual of each of these, right, subtraction property might look like 3 minus 1 equals 3 minus 1. I'm subtracting 1 on both sides. The division property, 3 divided by 2 equals 3 divided by 2. See, I'm just dividing the same number on both sides of the equal sign. And then the last one, multiplication, what might a definition of that one look like? Zoom in here so it's a little easier to see. Multiplication. Well, I can multiply the same number on both sides. So I have 3 times 2 equals 3 times 2. That's going to be equal. 6 equals 6. So what questions do you guys have about what I'm talking about here with these 4 properties? Okay. All right. Simplify. When I say simplify, I mean take a long string, do the algebra, and make it smaller. So for example, simplify. I could have something like 3 minus 2 times 10 plus 5. Let's do that. How do I sequence that? What's that going to be when I take 3 minus 2 times 10 plus 5? What's going on? Okay, explain why. 20, and that's a negative there, right? So 3 minus 20 plus 5. What do I do? Negative 15, yeah. Yeah. You see how I did all of that and it just got smaller and smaller and smaller and smaller? That's simplify. It's not the same thing as congruent goes to equal, equals goes to congruent. That's not the same thing. All I did for simplify was take my thing that was longer and make it smaller. Okay? So there's really not a good word way to talk about that. It's more of just something mathematical that we see. It's where you take the string of numbers and condense it down to its simplest form. Or another way of simplifying was with fractions, right? If I have 6 over 10, what's that as a simplified fraction? So you could say 0.6 if I converted it, right? Or isn't that the same thing as 3 over 5? Right? Can't I just divide 2 on the top and the bottom? That's what I mean, is I've taken something and made it simpler. And then the last one here, we know we can do this. Let's say we had 3x plus 5. And I know for a fact in this instance, x equals 10. What do I do with that? If I have x equals 10 and I know that 3x plus 5, what do I do? Couldn't I put in 10 for x? 3 times 10 plus 5? What did I do there? Ooh, substitution. I substituted, right? It's like I'm absent for a day and I have someone else take my place. They kind of entered into that position as they needed to. So substitution, I'm allowed to take in a number and put it in for a variable. That's something I'm allowed to do. So that's all of those properties that, like I said, we know what they are. It's just trying to put a word to that. So what questions do you guys have about any of these specific reasons that we can give? Okay, cool. Now you'll notice the third category. I call this just the geometry ones, okay? Because these are the ones that are like very specific to what we've done in geometry. Congruence isn't really something that we see in geometry and not really anywhere else. You guys tell me, remind me, what is this whole definition of congruence thing? What are equal? Absolutely. Measurement. Yeah. If I have a line that is that long, and then another line that is that long, would you say those are probably about the same length? Just about. Well, instead of talking about their measurements, right, I want to look at the shape. It kind of looks congruent. Okay? So what I'm talking about here is congruent means that the measures, that could be angle, that could be like measuring with a ruler, right? Any measurement that I make, those measures are equal. And notice the weird sort of like equals thing with the two little like hats, where it's like arrows going both ways. What I'm symbolizing there is if I see a situation where I go back and forth, back and forth, back and forth from equal goes to congruent, congruent goes to equal, equal goes to congruent, congruent goes to equal. What's happening there is the definition of congruence. It's the doc, right? It's the definition of congruence. So, what questions do you have about what the definition of congruence means? Okay, we just kind of fill a couple left, and then we'll actually try to work with this together. That way, moving forward, we'll be good to just kind of, okay, it's this, it's that, and we'll be able to recognize it a lot easier. Cool? So, segment addition postulate. It's the SAP. Exactly. Think of it like this. I have a segment here, because it's talking about segments, right? I have a segment here from A to C. And somewhere in the middle is another point. Let's just call that B. Cool? Well, from A to B, we can just call that AB. Sure, we can just label that as segment AB. And then same thing here. We can call this segment right there B to C. That means that the whole way across, the whole segment, well, we would call that A to C. What that means is AB plus BC equals AC. So if we have a situation with line segments, where we take part of the segment and then the other part of the segment and add them together and we get the whole thing, that is the segment addition postulate. It's the SAP, okay? It's the SAP that holds things together. It's kind of sticky and it adheres pretty well, like glue. So, what questions do you guys have about what the definition of congruence is, or what the segment addition postulate is? The last one here for us, for the geometry thing. Midpoint. What is a midpoint? Oh, I heard something. What's a midpoint? The point in the middle, right? So let's put a point in the middle right here. And if it's in the middle, you guys tell me, what do I know about these two segments that they cut? They're congruent. And I indicated that typically with the little dash right there, right? They're congruent. That's the definition of a midpoint. A point in the middle that makes two congruent segments. And that's typically labeled kind of like this. So if we see this, it tells us immediately this is the definition of midpoint. I have A, I've got B, I've got C, right? If I know B is in the middle and AB is congruent with BC, you see how I wrote this? B is somewhere in the middle, and I know for a fact A to B is congruent with B to C. That tells me that it's a midpoint. It has to be a midpoint if it cuts it exactly in half. That's the definition of a midpoint. B is in the middle, and AB is congruent with BC. What questions do you guys have about the geometry properties? All right. Last part. I tend to think of these ones as a little bit of the easiest, just because it's fairly intuitive. Reflexive. I used the analogy, if you remember, of having a mirror. Like we're looking in the mirror and seeing something. You guys tell me. I kind of look in the mirror sometimes, but if I look in the mirror, what do I expect to see? me, right? Myself. And so if I'm looking into a reflection, kind of like Mulan looking in the water, I should see something like A equals A. A number is always equal to itself. Or I could see something like line segment AB is congruent to line segment AB. It's the same thing. I look in the mirror and I see myself. I kind of draw that line to say mirror, right? Just kind of illustrating that a little bit. I should see my same thing, okay? Which is different than symmetric, the symmetric, okay? Symmetry means I'm going to take the same thing, but it's like inverted. You see that? It's like I took the same thing. Like I have two hands that are a little identical. My right thumb's a little smaller than my left thumb. But still, I have the same sort of shape, just symmetric, like butterfly wings almost, right? So when I'm talking about the symmetric property, here's what I'm saying. AB is congruent to BA. It's the same thing, right? I'm talking about line segment A to B. It's the same thing. The only difference between the symmetric here is I took my letters and I inverted them, as in like I swapped the order of them. It's symmetric. It's like butterfly wings. It's the same pattern, just backwards. What questions do you guys have about the symmetric property? Okay. The very last one, transitive. Okay. It looks something kind of like this. Let's suppose 3 is equal to the letter X. Okay. But also, the letter X happens to be equal to the letter Y. What is Y equal to? How do you know? Huh, isn't that weird? Yeah, so it says 3 is X. Let me just bring it here. Yeah, 3 is X, but X is Y. So what is Y? 3. How do we know that Y is 3? Interesting. Let's break that down. If A happened to equal B, and B happens to equal C, then what can I say about A and C? What do I know about A and C? Aren't they also equal? Right? Then A equals C. Yeah, exactly why. A equals C. It's what we saw here, right? If 3 equals X and X equals Y, Y equals 3. They're all equal. So if we run into a situation where I say, well, this is equal to that, and that's equal to these, and this is all equal to that, and they're all equal, right? It's kind of like I'm looking at that weird board with all the different, okay, you did this and did that and this. It's all connected, that conspiracy theory looking thing, right? They're all equal here. So that's our giveaway. If we see a situation where they're just all equal, we know it's the transitive property. So this is all of the reasons we can use. What questions do you have about any of these concepts, specificity, any level of what any of these mean for us? Okay. Go ahead and stand up.